Okay, we're taking a look here at section 4.8, part 1, and we're starting down here at the middle, and it says, if we have a polynomial function, the following statements are equivalent. So you need to understand that if k is a 0 of the polynomial function, that also means that x minus k had to be a factor of the polynomial. For example, let's say that we have x equals 3, and that's going to be a 0 of the polynomial. How would that look as a factor? X minus 3. Good. So that's all we're saying there, is that those two are related. If something's a 0, x minus that value has to be a factor. We can also talk about solutions. Solutions, or roots, are the same thing as zeros. Solutions or roots are the x values that make the function equal 0. Also remember that an x-intercept is going to be where the graph passes through that value of k0. So if k is an x-intercept and k is a real number, then the graph is going to pass through that point. So if we say x equals 3 is a 0, that means 3, 0 is the point. Alright, so this first problem is just reviewing how to find all the zeros. First of all, how many total zeros should we have? 3. So total should be 3. Then I might want to make a PNI chart for positive reals, negative reals, and imaginaries. I look at the number of sign changes. How many sign changes do we have here at the beginning? 1. So I have to have one positive real. That's the only option. If I plug in a negative cubed is negative, negative squared is positive, times negative is negative, a negative times negative is positive, and then negative 15 is negative. So when I plug in the negative x, that's what I would get. How many sign changes now? 2 sign changes. Negative to positive is 1, positive to negative is another. So 2 negative reals are possible. How many imaginaries would we have in that case? 0. Okay, we could also have 1 positive real, but how many negative reals? 0. In which case, how many imaginaries? 2. So now I would like to look at what are the possible rational roots. So I look at the factors of 15. They are 1, 3, 5, 15. This is my rational roots theorem. Then I look at the factors of 2, 1 and 2. So our possible rational roots, I'll call that PRR, possible rational roots, are plus or minus 1, 3, 5, 15, 1/2, 3/2, 5/2, and 15/2. So all of those are going to be our possible rational roots. Now we have to think, which one would it make the most sense to check? A positive or a negative? A positive, because I have to have one positive. So I have to decide which positive I want to check. I'm going to check 1. I'd like to show you another way to do synthetic division a little more quickly. Now this might be a little confusing at first, but it's something that'll take some practice. Here's what I'm doing. I'm going to make a chart. I'm going to put 2, negative 3, negative 32, and negative 15. Those are my coefficients. What would be a good positive rational root to check first? 1. So I'm going to put 0 here, and I'm going to check 1. I'm checking the number 1, that's the x value. So I bring down my 2. This is the number that I am using. So I do 1 times 2, and I add it to negative 3. I'm doing synthetic division, but I'm not showing every step. Let me show you again what I'm doing. These are my coefficients of my polynomial. I bring down the 2. I do 1 times 2 is 2, and I add it to that. What would that give me? Negative 1. I do negative 1 times 1. What does that give me? Negative 1 added to that is negative 33. I do negative 33 times 1. That's going to give me negative 33. And when I add it to that, I get negative 48. We're going to start doing synthetic division all in one chart. Okay? And that's a little bit different than what we've been doing before. What would this number here represent? The remainder and also the y values. So if I plug 1 into that function, I get negative 48. I want you to think about the end behavior before we go any further. This is a cubic, and it has a positive lead coefficient. What is the end behavior? Up, up, down, 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 up, or up, down? Down, up. Because when it's odd, it always is going to be the opposite, and because it's a positive at the beginning, it starts off like x to the third, looks like that. Okay. Alright, so if I know it has to end up, that tells me this isn't even a positive number, and I have to end up. So I am now going to go ahead and check 3. I'm going to bring down the 2. 2 times 3 is 6. I'm going to add it to that. 3 times 3 is 9. I'm going to add it to that. Negative 23 times 3 is negative 69, and I'm going to add it to that. And that's what I get for y when I check 3. What did I say has to happen as x goes to infinity? Y must go to what? Positive infinity, and it's not yet. So I am going to go ahead and check 5. I bring down the 2. 2 times 5 is 10. I add it to that. 5 times 7 is 35. I add it to that. 3 times 5 is 15. I added to that. Great. Why is that so good? That's our 0 finally. So for my zeros, I have one of them. It's x equals 5. Now I know that this is my constant, this is my x, and this is my x squared. So what I have left is 2x squared plus 7x plus 3. If I set that equal to 0 and solve, those would be my other two zeros. You should always be able to solve a quadratic equation. You have the quadratic formula, you have factoring, and you have completing the square. I multiply 2 times 3 and I get 6. Are there numbers that multiply to be 6 and add to be 7? 1 and 6. So I'm going to set up my double parentheses. I get a 2x and an x. If I have to get a 6x and a 1x, what am I going to put here to get the 6 that I need? And what am I going to put here? And now let's check. 2x squared, 6x and 1x and 3. So that's good. What about the signs? Plus, plus. And so do you know what our other zeros would be? Good. So we did end up with 1 positive real zero and 2 negative real zeros. Remember on the last quiz where I always gave you a 0 or I let you use your calculator to find a 0. Now we're trying to get more advanced to where you can find the 0 on your own without having to find one in those other ways. How do you feel about that synthetic division? It feels difficult right now, doesn't it? But next year in pre-calc, they're going to expect you to do that from day one. And so that's why we practice fighting.
So step 2, how did you get the second row?
Right here.
Yeah.
Because I know that negative reals have to occur. I get 2. Do you know how I got the 2?
Yeah, I got that.
Okay, and then you subtract 2. Because the imaginaries always occur in pairs.
Okay.
So that's just another option we can have.
Why'd you put a 0 over the 1?
Why did I put... Just so that I knew that, like, in case I ended up having to check negative numbers, I just wanted to have space in case I wanted to check the negatives. I mean, I could have put these up here further, but see what happens is, like, let's suppose I just kept going and I wasn't finding any positives and I wanted to check negative 3. Let me check negative 3 here. I just want to review this again, guys. What do I do first if I'm checking negative 3? Bring down the 2. What's negative 3 times 2? Add it to that, what do you get? Negative 3 times negative 9. Positive 27. Added to that, negative 5. What's negative 3 times negative 5? Added to that. See how that's just another 0 and we already knew it, right? But let's say that we couldn't factor this and we were just confused on how it works. I just wanted to leave myself some space in case I wanted to check other values. Seth?
How are we able to get the other zeros?
These other zeros right here?
Yeah.
I just used factoring.
Okay.
But I could have just kept doing synthetic division with all these other possibilities. But my thing is, once I get it to a quadratic, I can always solve a quadratic. So I'm not going to bother doing the synthetic division for, what is that, 4, 8, 16 possibilities. It's just too much work. Okay? Guys, this is something you'll have to practice, but you have like a week and a half to work on it. So we don't have our test until not this coming block, but the following. All right, guys, one more little thing here, and this will make a lot of sense after what we just did. The location principle says this. If f is a polynomial function and a and b are two real numbers, such that f of a, meaning the y value when you plug in a, is negative, and the y value when you plug in b is positive, then the function must have a real 0 between a and b. Alright, I'm going to write down a bunch of points here. This is x and this is f of x. Let's do negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3. Alright, and I'm going to put down some y values. Negative 11, negative 8, negative 2, 4, 6, 5, negative 2, negative 5. I'm just making up some random numbers here. So what the location principle says is that if I have a y value that's negative and then a y value that's positive, wouldn't the function have to pass 0? Let me do a little graph for you here. So at negative 4, we're at negative 11. Negative 3, we're at negative 8. Negative 2, I'm at negative 2. Negative 1, I'm at 4. 0, I'm at 6. 1, I'm at 5. 2, I'm at negative 2. 3, I'm at negative 5. And I'm just kind of, randomly putting these in here. The question is asking me, between what integers do we have to have zeros, real zeros? Well, looking at this chart, can you see how this y value is negative and this y value is positive? Doesn't there have to be a 0 in between there? So what are the x's that are causing me to have those zeros? Between x equals what? Negative 2 and x equals negative 1. There has to be a 0 there in between negative 2 and negative 1. Okay? Where is the other place that there must be a real 0? Between which x's? Right, so between x equals 1 and x equals 2, there must be an x-intercept, or there must be a 0. Okay, so what about on this one? We're told f of 2, that means when x is 2, y is negative 3. F of 3 means when x is 3, y is negative 1. When x is 4, y is 2. So between which two integers would there have to be an x-intercept? Would there have to be a 0?
3 and 4.
Yeah, between 3 and 4. So the reason that we study this is, let me go back to this chart we had. Remember how this chart tells us the y values? So let's say I did this and I found that this was negative 48, but this was positive 84. Wouldn't that tell me then that there has to be a 0 in between 1 and 3? That's the whole reason we do this, is because when we get into like harder problems, we would then recognize that there has to be a 0 there. So that 0 between 1 and 3, out of all of these options, between 1 and 3, I would know maybe I should check this one or this one, because there has to be an answer between 1 and 3 that's a real 0. Okay? All right, we're going to stop there.